you've used any electronic in your whole life, odds are it's had a battery in it. But how do batteries actually work? And what does how many volts it has have to do with anything? Hi, my name is Callum, and in today's video, I'm going to be talking about what a battery is, how it works, and what voltage actually is. In order to explain how a battery works, I first have to explain what voltage is. And in order to do that, I'm going to use something a lot more intuitive, gravitation. Let's take this cube. Here, it has some gravitational potential energy, right? What does that mean? Well, if I were to drop this cube from here, it would have a certain amount of velocity the instant before it hits the ground. If I move it up here, I hope that you can agree with me that it'll hit the ground at a faster speed because it's higher up and therefore it has more gravitational potential energy. Now, since we are at the surface of the Earth, we can use this equation. mgh equals the potential energy, gravitational, right? Where m is the mass of this cube, g is the acceleration due to gravity, 9.8 meters per second, and h is how high it is. Now, as we can see, when I increase the height of this cube, it has more potential energy, right? As this increases, so will this. If I were to decrease h, so would the potential energy. If I move it lower, it has less potential energy. Now, keep in mind that my hand is the thing that's moving this cube up and down. In turn, going from here to here, the cube gains potential energy. So let's use that same idea of your distance away from something kind of correlates to how much energy there is, or potential energy, I should say. So here, we have a positively charged plate on the bottom, down here, and we have a negatively charged plate up here. Now, if I were to put an electron right here, say, the speed at which it reaches that positive charged plate, obviously it's going to move towards the positive because negative and positive are attracted and negative repel. Same thing with positive and positive repel. So going back to this, the speed at which it reaches this plate is entirely dependent on the distance, right? So we'll call this distance x, okay? Now, if I were to put an electron all the way up here, sure, it has more distance to cover, right? So yes, it'll take more time to reach this plate, this positively charged plate. However, the final speed it has down here will be far greater because it has had much more time to accelerate. So we'll call this distance, we'll call this h. Now, the idea of voltage is simply a way to define how high or how far away you are from a charged plate. So here, we'll call this 1 volt. Okay? Now, let's say over here, this is 8 volts. Okay? And this whole thing, the total amount of potential energy across this whole thing is 9 volts. Now, notice how I said potential energy. What voltage is electric potential energy. Just as with gravitational potential energy, as I move my hand farther and farther away from the ground while holding the cube gains more and more potential energy. If I move this electron farther and farther away from this positively charged plate, it will gain electric potential energy, otherwise known as voltage. So here, at a distance x away from this plate, it has 1 volt. That's not a lot. Notice how it's pretty close to the positively charged plate. If I move it a lot, it's going to have a lot more potential energy, hence 8 volts. And again, the thing I really want to drive home here is if I were to let go of this electron, if you will, what will it do? It'll just jump straight to that positively charged plate. So it's losing its potential energy up here. It has if I'm holding it in place here, it has the potential to end up here if I just let go of it. It has the potential energy up here, and the second it gets the chance, once nothing is holding it back, it's just going to accelerate and convert all of its potential energy to kinetic energy right here. At the instant before it makes contact, it will have at its maximum kinetic energy. Now, doesn't that sound useful, having electrically charged particles move? Now, let's just say we add in a wire right here, connecting this positive charge plate to this negative. If you know anything about circuits, you'll realize that this is a short circuit, but for the sake of this video, let's say we have electrons, right? And we have something that moves this electron upward, and then we get this electron on the other side of this barrier. Okay, so now this electron is in that wire. Now it starts to flow, and let's say we have a light bulb right here. Sorry for the drawing. We'll say that's a light bulb. Now this electron will pass through this light bulb, giving off energy and powering the light bulb. Right? It's powered up, and then it will continue towards the positively charged plate. Keep in mind that this electron, while yes, it is powering this light bulb, it's not really attracted to the light bulb, if you will. In reality, what it's attracted to is this positively charged plate. This electron just, it doesn't care that this light bulb is there. It's just like, oh, it's on the way, but where I'm trying to go is this positively charged plate. This is exactly what a battery does. It has a positively charged plate and it has a negatively charged plate. Well, in reality, sorry, let me switch this. In a standard battery, technically, this would be the top, but we'll look at it upside down, it's fine. So, as electrons are pulled from here, and they're traveling upward, they're going to gain potential energy. Now begs the question, how do we actually move the electron from here to here and store that potential energy? Recall, when I was holding that Rubik's Cube and I moved it from here to here, it was my hand that was pushing the cube, doing work, in order to increase the amount of potential energy it has. So in this case, what's causing the electron to actually move up? Now in this case, there's not an actual hand per se moving the electrons up. Instead, what's moving the charged particles, I should say, away from the oppositely charged pole is something known as an EMF, an electromotive force. EMF. Now, an EMF is often notated by the Greek letter epsilon. Now, what is the EMF? Well, it's the force that is moving the charged particles away from where they want to go, if you will. So, what's moving this charged particle away from this positively charged plate? Now, what exactly is that EMF? In most batteries, it's chemicals that are causing that push. So I won't get into the actual chemistry of how that works, mainly because I don't know. But in many cases, it's lithium. Especially like when you're flying, you hear, oh, no lithium on batteries and stuff. So the chemical properties of lithium are pushing the charges from one end of the battery to the other, in turn increasing potential energy, increasing voltage. Now, when a battery has a notation, for example, a 9-volt battery, all that means is that the maximum amount of energy, or the maximum amount of potential energy it can store, is 9 volts. Recall back to when I was showing you those two plates where we had a positive plate on the bottom and a negative plate at the top. Down here, we'll call it, ignore this little space here, we'll call this 0 volts. And all the way up here, we'll call this 9 volts. So the distance that the EMF is, or the lithium in this case, is pushing the charged particles results in an increase in potential energy or voltage of 9 volts. It goes from having no potential energy, 0 volts, and then as a result of the EMF inside the battery, the lithium inside the battery separating the charged particles, it goes to having potential energy at 9 volts. So that's what a battery actually is. It's simply a means to move charges from one place to another via the EMF and store that in order to discharge those charges later. So we move it from here to here, and now there's potential energy inside of this thing. And if we were to attach wires and stuff, then those electrons will flow and come back around. I really hope that this video helped you understand what a battery actually is, what voltage means, and if you guys have any questions at all, I urge you guys to leave them in the comments or look them up yourselves and keep learning.